So before I start on the topic of simple interest, I want to go back and talk about rates because simple interest has a rate built into it, and knowing how to work with a rate is really important for figuring out a lot of the problems that I'm going to give you. So let's take a simple problem here. Generally, a person can walk at about 2 miles per hour. And my question is, how far can a person walk in 15 minutes? So there's a formula for distance. It's equal to rate times time. And the rate in this case is 2 miles per hour. And the reason that it's a rate is because you can write it as a fraction, miles per hour. So anytime you can have two measurements with the word per in between it, it's considered a rate. All right, so let's plug in what we know. I don't know what the distance is, so I'll leave that alone. I know the rate is 2 miles per hour, and I'm going to write in miles per hour here just to be really clear about what's going on. Now, my problem is time. If I put in 15 minutes here, and I do my calculation, I'm going to end up with 30 mile minutes per hour. And that doesn't make much sense. The key thing here is we want to convert things into hours. I don't want to convert away from hours because when we get into working with simple interest, it's more important to change the time frame than it is to change the rate itself. So I'm going to go through the process and changing minutes into hours. So I'm going to put this over 1, and I'm going to multiply it by something with minutes in the bottom. Does this sound familiar? Sounds like module 1, converting units. And then in the top, I'm going to put hours. So for every 1 hour, there are 60 minutes. So here, the minutes are going to cancel, and we're going to be left with hours here and hours in the bottom. So let me rewrite this. So now I have distance is equal to 2 miles per hour times 15 sixtieths of an hour. And of course, the hour is in the numerator now. All right, so now we have the setup that we want, and the hours are going to cancel each other. So this calculation here is actually quite simple. You're going to put 15 minutes in the top, and 60 minutes in the bottom represents per hour, and that way you get 15 sixtieths. So after the hours are gone, the only measurement left is miles, and now we get 2 times 15 is 30. 30 divided by 60 is a half. So in 15 minutes, we would expect to go half a mile. So this idea of changing the time to fit the rate is extremely important for simple interest. So let's talk about interest for a bit. The concept of interest that a bank charges or you earn on a savings account is the idea that you pay a fee or get paid a fee for borrowing, and if you're saving, then it would be for saving money. So you're charged money to borrow money, and the bank pays you money literally to borrow your money when it's in a savings account. By the way, that money doesn't just sit in your account. The bank uses it for an investment so it can earn a higher interest rate than they're paying you. So borrowing money and saving money are technically just two ways of looking at the same thing. All right, so you're going to pay a fee to borrow money. So if you had just a flat fee, like, you borrowed $100 and the bank charged $25 to borrow this money, it makes sense if they, got their money back pretty quickly. What wouldn't make sense is if you paid them back in 50 years. So you borrow $100 from the bank, they're only charging you $25 to borrow it, but then you don't pay them back for our 50 years. Another thing that affects money is this idea of inflation, that as time goes on, money becomes worth less. For instance, my parents bought their house back in 1958, I think it was, and they paid $10,000. Um, Now, today in 2020, the house is worth closer to about $100,000. So the money that they spent way back in 1958 and today's money of 100,000, they're equal because they would pay for the same house. So a bank allowing you to take as long as you wanted to pay them back doesn't make sense. So what they come up with is an interest rate. Now, there is a big difference between interest, which is money, up here this is money, and an interest rate, which is percent per time. So now we have to pay a percent based on how long we've kept the money, and that actually makes it a little bit more, well, fair to all sides. Of course, if the interest rate is really high, not so fair. All right, so when we talk about interest, we also have to talk about interest rate. A few other little terminologies. We're going to have a principal. Now, a principal can be how much money you borrow, or how much money is saved. And generally, we don't let the principal change to start off with. You know, you're going to borrow $1,000, your principal stays $1,000 until you pay off your loan. So that's how simple interest works. We'll get into monthly payment loans later on. It gets a little more complex. So far we have interest, which is money. We have interest rate, sometimes just related to as rate, the rate of the interest. And we have principal. So of course then there's going to be time. And if all goes well, we try to keep time as one time frame. The easiest one, of course, is years. So when we talk about an interest rate, we generally talk about APR, which is an annual interest rate, percentage rate. Annual percent rate. And APRs are the most common types of interest. Credit cards get a little different with how they deal with an APR. They make it a daily interest rate because your balance can literally change every single day. Other things could be, monthly rates, like credit cards. Well, I shouldn't say credit cards. Personal loans. But generally, they all back off to an APR, an annual percentage rate. So putting these all together, we have interest, we have interest rate, we have principal, and we have time. That's going to give us a formula. And the formula is interest. Now this interest is the money one, is equal to principal, which is also money, times R. This is always that APR or the interest rate, times time, and this is usually in years. Usually, but not always. So this formula is very similar to distance equals rate times time. All right, so this is the main formula for simple interest, and we have to figure out how to use it next. All right, so Paul borrowed $1,500 from his mom. His mom's not too sure or wants to make him pay it back quicker than he'd probably want to, so she's going to charge him 8% APR simple interest on this loan of $1,500. How much interest will his mom charge when he pays off this loan in 8 months? I should put when here. All right, so let's start it off. Whenever you do one of these problems, it is best to write the formula down and plug in what you know and leave alone what you don't. So do I know how much money that Paul's mother is going to charge him? And the answer is no, so this I stays as an I. Do I know the principal of this loan? And the answer is yes, it's right here. He is borrowing $1,500 from his mother. So $1,500 will go here. Times, now the interest rate you have to be a little bit more cautious with. You cannot use 8% in the formula. You're going to have to change it into a decimal. So if you're unsure of how to do that, just write it as 8 over 100. That'll automatically change it into a decimal. Your calculator is going to do all the work, so leaving it as 8 out of 100 is not a bad idea. If you want to simplify it to 0.08, that's fine also. And then we're going to multiply this by the time. Now the time is 8 months. Now if I put 8 here, that doesn't make any sense because the 8% is per year because it's an APR. So if I put 8 months here, then that's not going to work out because the time frame isn't going to cancel. So I have to change 8 months into a year, and the quickest way to do that is to divide by 12, because 12 months, and the only thing I'm leaving off is the 1 year that the 12 months is associated with. So we're just going to divide the 8 by 12. So this becomes, let me erase this, it's kind of too big, 8 over 12. Now this is 8 months out of a year. And the year, of course, is represented by 12. So 8 months out of 12 becomes our time. 8 over 100 is our percent, and 1,500 is our, 8 over 100 is our rate, and 1,500 is our principal. So we just have to type this into our calculator and get a nice answer. So 1,500 times 8 out of 100 times 8 out of 12 for a grand total of 80. So we're going to get I is equal to $80. Now there's no time frame left over because the years will cancel, the months will cancel, and the only thing left is a percent of dollars. So we get $80. Now, this just tells me how much his mother is going to charge him for borrowing the $1,500. So then next question, which is kind of obvious, how much will he have to pay back? And this gets into another concept that's really important to understand. It's one of those, what I consider common sense formulas, because it makes sense that if he borrowed $1,500, she's charging him $80 for the borrowing. She's going to want both of them back, the $1,500 and the $80. So we get this formula. We're going to call F the future value of the account, the borrowing. So F is always going to represent the amount that is owed or the amount the account is worth. So this is called the future value of the money in play. P, of course, is our principal. So that would be the $1,500, and we're going to add on to it the interest. So this becomes really important to understand that, sure, she's going to charge $80, but the amount that he needs to pay back is the future value. So in this case, the future value is $1,500 plus 80. And it sounds ridiculous that I'm spending a lot of time on this common sense formula, but a lot of people make mistakes with this formula, and it has two other variations to it, which are also quite important. All right, so let's look at another possibility. So here I have Nakia borrowed $850 from her dad. In 15 weeks, she paid her dad back $1,000. So my question is, what is the APR that he charged for this loan? So this might be just an agreement between her and her dad, and, you know, he just wanted $1,000 back from her after 15 weeks. So we're going to start off the same way. We're going to write I equals PRT. P times R times T. So when I asked, do I know the amount of interest that was charged on this loan? And directly, I don't see it in the problem, so I'll leave that as I for now. Highly suggest you don't copy this down if you're writing in pen. Wait a second for what's going to happen. Do I know the principal of the loan? Now I have two numbers to choose from. I got the 850 and the 1,000. But P always represents how much you borrowed or how much you saved. And she only borrowed $850. So that has to be the P. The interest rate is what we're looking for because that's part of the question. So we'll leave that as R. And then T is that 15 weeks. Now remember that 15 weeks, we want to convert it into the year. And the easiest way to do it is to write it as 15 weeks out of how many weeks are in a year, which is 52. So the bottom number is going to be how many in a year. Would be kind of a shortcut to go about converting the time into years really quickly. All right. So now there's a problem with this formula, and the problem is this. I have two variables left over. I have this I and I have this R, so I really can't solve for anything. So I have to look at the problem again and decide, do I know one or the other based on the information that I'm given? Now, there is a bit more information in this problem that I haven't touched, is this 1,000. Now, that 1,000 represents the future value of the account. So we're going to have to play with this formula, and as well as the simple interest formula. Now, I know the future value of the account is 1,000. I know the principal of this account is 850. So the common sense would be to find the interest, the amount of money that was paid to borrow this money to begin with, is the difference between 1,000 and 850. And in fact, to solve this equation, you have to subtract 850 on both sides, which would be 150? 150. So the amount of interest that he charged her was $150. So by using this formula, I can now plug more information into that formula and have 150 is equal to 850. Oops, that's an ugly 5. Ooh, it's still ugly. Times R, and there's no point in reducing the fraction, so I'm just going to leave it as 15 over 52. All right, so this is not a pretty situation yet. I have to get the R by itself. So my goal is to solve for R. Now, going back to algebra, to solve for R, you have to undo any operations that are next to it. So I might as well start with the 850. 850 and R are connected by this little multiplication symbol. So to solve for R to start with, I'm going to undo multiplication by dividing by 850. Now I'm going to leave it as 150 over 850. Because remember, I'm going to let my calculator do all the work. So 150 over 850 is now equal to R times 15 over 52. Now, a neat little trick about fractions is that 15 is multiplying R. So to undo multiplication, I would divide. And 52 is dividing R because it's in the denominator. Remember, back to converting units, anything in the top is multiplication, anything in the bottom is division. Then to undo both of those operations really quickly, I'm going to multiply this side by 52 over 15. So the 15, instead of being multiplied, now is divided. The 52, instead of dividing, is now multiplied, and they'll cancel each other out rather nicely. They're also known as multiplicative reciprocals if you want fancy language. All right, on the other side, you'd also multiply by 52 over 15. So that'll get r by itself, because we have a big fat 1 here. And 1 times r, I'm going to switch sides, is r. And then in my calculator, I just have to do probably the safest one is to go in the order of each fraction. So 52 divided by 15 times 150 divided by 850. Because if you try to do 52 times 150 divided by 15 times 850, you're going to get the wrong answer because you've just moved the 850 from the bottom to the top in your calculator. So this is much safer to type in fraction multiplication times 150 over 850. And let the calculator do its work. So 0.61, and I'm going to go 3 decimal places. There's a reason. So 0.612. So this is 0.612. All right. Whew. And you think you're done because you think this is the APR, 0.612, but the problem is we want to write it as a percent, and this is one of the trickier things about percent, recognizing when you have to change a decimal into a percent. Most people understand how to change a percent into a decimal. So you have to understand when we're dealing with R here, this has to be written as a percent. So to write it as a percent, I'm going to have to multiply it by 100, and this becomes 61.2%. So it started off looking like Dad was being nice with his APR, 0.612, but it turns out that he's charging more than a credit card interest rate, and definitely more than a bank rate. So poor Nakia, she's getting ripped off. And that's how you would find an APR in this situation. Now, let's talk about the future value formulas. So the future value formulas are the common sense one. The future value of an account is equal to the principal plus its interest. But if I rearrange it, we actually did this in the last problem. We actually had I is equal to the future value minus the principal. So if you borrowed $100 and you paid back $150, then your interest is $50. And then the last formula is if you're, it's not very common, but the principal can also be written as F minus I. But these are the two most common versions of the future value formula. And again, they are common sense, but you have to think about what number are you dealing with. And most people have a very hard time figuring out if they're looking at a number that is the future value or if they're looking at a number that is the principal. All right, so here's a question. Jose borrowed some money 15 months ago, but because it was so long ago, he forgot how much he borrowed, but he does remember that his interest rate was 9.5%. And when it's not written with an APR, you can assume that it is an annual percentage rate. If it was, percent per month or percent per week, it would have to say it. So if it doesn't say anything about the time frame, you assume that it is per year. All right, and he had to pay back this $5,034.38. So my question is, how much did he borrow to begin with? All right, so let's start off like we have been with the simple interest formula and see where it gets us. Times R times T. All right, so do I know the interest in this problem? And when you start looking at the numbers that is given to us, we have this number, which is definitely not interest. We have this, which is the interest rate. and we have this number up here, which is just, well, the time. And the 50/34/38 is how much he has to pay back at the end of the loan, so that's actually the future value. Okay, so if I say, well, what is the interest? Since I don't know, I'm just going to leave it alone. Do I know the principal? And the answer to that is no, because that's what we're looking for. We're looking for how much did Jose borrow. So that gets left alone. We know the interest rate is 9.5 out of 100. And we know the time is 15 months out of a whole year. So it's 15 months out of 12 months. So it's a little bit more than a year. All right, now there's a problem with this, and the problem is pretty glaring. We have two variables left over. So maybe what we did last time will work. We can use that trick. The other formula, what I call the common sense formula, is future value is equal to principal plus interest. But I run into the same problem here. I don't know P and I, so there's no place I can go. So we're going to have to create a whole new formula for this problem. All right. So the way that we're going to get this new formula is we're going to actually take this formula, the one that didn't work earlier. So we're going to have F equals P plus I. And we're going to kind of join it with this formula and see what happens. So these two formulas we're going to kind of work at the same time. So if I is equal to P times R times T, then I can replace this I with P times R times T. So I get F is equal to P plus P times R times T. It's called substitution. You can replace equal values with equal values. And therefore we get this little formula. Well, I want to make it a little bit nicer. I think there's an easier way to work with this. So let's go off to the side here and do some side work. So if I asked you what's 2x plus 3x, most people would be able to tell me that this is equal to 5x. The problem is if I asked them why it was equal to 5x or prove it's equal to 5x, they wouldn't be able to do it because they're used to the shortcut. So there is a property in math called the distributive property. And it pretty much works as you have a number times a set of parentheses that has addition or subtraction in it. And we can just expand this as a times b plus, and then we would multiply the a times c. Most of you have seen this property at some times in your schooling in the past. So in this direction, it's called the distributive property. If we go backwards and we say, well, these two terms both have an a. So if I kick it out, what's left behind is going to be b plus c. So that's also known as the distributive property, but most people call it factoring. So if I do that to 2x plus 3x and recognize that x is the common term, I can kick it out. Now, when you kick something out with factoring, it's usually kicked out with its opposite operation, which is division. So to find what's left behind, let's go purple. You're going to divide both of these guys by x, which is represented by him, and 2x divided by x is just 2, and 3x divided by x is just 3, and all of a sudden we end up with what I expected, which is 2 plus 3 is 5 times x. So that's why 2x plus 3x is equal to 5x. It's the distributive property. Now, after that all being said and done, let's go back over here. And you'll notice these two terms, there is a like term. They both have this p. So what I'm going to do is I'm going to pull the p out. So I'll get f equals, and I'm going to kick the p out. Now you have to, let's change some colors here. You have to take this p and divide it by this p, and when you do that, you're going to get 1. P divided by p is 1. What the heck is that? P divided by p is 1. Plus, And then if we do the same thing for PRT over here, PRT divided by this P is going to also equal, P divided by P cancels, and you're left with RT. So we get this new formula, R times T, which gives us the future value. So it's a formula that kind of skips over finding the interest first and jumps right to, I'm not worried about how much I'm charging you for this loan. I want to know how much you owe me for this loan. All right, so let's see how this formula works in this case. We have F equals P times parentheses 1 plus R times T. And I'm going to go through it just like I do I equals PRT, one letter at a time. Do I know the future value? And the answer is yes. The future value is right here. It's 50, 34, 38. 50, 34, 38. Do I know P? And the answer we already know is no, so I'm going to leave it alone. Parentheses 1 plus, I know R is 9.5 over 100, or you can write it as 0.095. You have to be careful. I've seen people write it as 0.95, and that's why I like putting it over 100 instead. And we know the time is the 15 months out of a year. All right, now to solve this equation for P, we're going to use the opposite operation of this. It's P times what's inside the parentheses. So the opposite operation is to divide both sides by what's inside the parentheses. Now, once you do that, these two parentheses are going to cancel each other out. They're exactly the same. You're going to get the P by itself. So we'll get P is equal to, and in a calculator, what you want to type in is 503438, decimal 38, divided by, and really important, I'll do this in color, you're going to have to put the parentheses and then everything that follows it. 1 plus 9.5 divided by 100 times 15 over 12. And the reason that you really want to do this is you're going to get a really precise answer. If you took this and typed it into the calculator first, came up with a decimal, rounded the decimal way too much, and then divided it, it generates what's known as rounding error. So it might actually throw your answer off compared to what Mobius will be looking for. So you could be doing the problem completely right, but because you rounded too much, you're going to generate rounding error. So if you do the purple stuff first in your calculator, round it to like 4 decimal places. Probably 5 would even be better. But if you do it this way, you don't have to worry about rounding error. It'll give you a nice answer. And you'll see that it comes out, a little bit off at the end. But if we round this to the nearest penny, this is just $4,500. So the amount of money that Jose borrowed is $4,500. So that is the power of this future value formula. It allows you to solve for P. So if you have to solve for anything else, I, R, T, you can use the simple interest formula, I equals PRT. But if you have to solve for the principal, this formula is the only one that allows you to find it. One of the trickiest types of loans around are called discount loans. And these are usually the check cashing companies that will lend you money based on a previous paycheck. And when your next paycheck comes to them, they just take the whole thing. They generally charge you interest up front, and that's why it's a little different than a regular loan, and it has this word discount in front of it. So discount loans, you pay the interest at the beginning. You haven't even borrowed the money over a period of time, and let's call it the bank, wants their money up front before they even give you the money to put in your pocket. So these are a little bit of a deception of a type loan. And that's why years ago, check and go places in North Carolina finally became illegal. They're starting to crawl their way back in, finding loopholes, and there's other really dangerous loans like these out there. So be really, really careful when you borrow money. Find out if you're paying the interest first or last, and always know how much interest you're going to have to pay to borrow that money. All right, so let's go through what a discount loan does. For example, Mary. All right, so here I have an example. Mary borrowed $2,500, $2,500 on discount at 35% APR for 1 month. How much money will Mary truly get for this month? Because when you get a discount loan, they take the interest first, and the only money they can take the interest from is the amount of money you're borrowing. So we're going to set this up as I equals PRT to find out how much money they're going to charge Mary for this money. So we'll get I, we don't know what that is. P is the $2,500 she's borrowing. The rate is 35%, and it's not uncommon for it to be even higher than that. Times T, which is 1 month out of a year. So 1 month out of 12 months. All right, so let's figure out what this is equal to. 2,500 times 35 out of 100 times 1 out of 12. So 72.92. So this is the interest that the loan would require to be paid. So you're not going to give it to them in cash. You don't have the cash. You're trying to get a loan here. So what they're going to do with the 72.92 is take it away from the amount you borrowed to begin with. So your true principal is going to equal 2,500 minus the 72.92. So you're only going to go home with. Now I'm subtracting this backwards, so it's going to come out negative. You're only going to go home with 24.2708. 24.2708. So technically, this is how much money you're really borrowing, because that's the only amount you're going to be able to keep for the entire month. And then at the end of the month, you have to pay back, take a guess, $2,500. All right, so this being the case, then the interest cannot be 35%. It's going to have to be a little bit more because you just borrowed less, but still had to pay back everything at the end. All right, so let's find out how much the interest rate really is. So we know what we're going to set up I equals PRT again. But in this case, we know what the interest is. It's right here, 72.92. We know how much money we had for the month. That's that 24.2708. It's not 35% anymore because you're borrowing less money and you're still paying the same amount of interest. So the interest rate's going to have to be more. So we're going to leave that alone, R, and then the T is still the same, 1 month out of 12 months. So to solve for R, there's a couple of different things you can do. You could do the numbers that are on the right-hand side. So we could multiply this guy and this guy and come up with a decimal. And like I was talking about in the last problem, as long as you round to 4 or 5 decimal places, it shouldn't cause too much trouble. 24.2708 times 1 over 12. So we get 202.2566. So 202.2567 if we round it times R is equal to 72.92. All right, now we have a little bit of a problem. I have the 202.2567 number in my calculator, but I want to divide both sides by it. Now, there's nothing to save it. You're going to just have to write stuff down. So we're going to have to divide both sides by this 202.2567 to get the r by itself. 202.2567. 72.92 divided by 202.2567. Here's our problem. This is a decimal, but we know we're solving for r, and we know r is usually written as a percent, so we're going to have to multiply this by 100 to change it into a percent. So this is 36.1%. So they advertise the loan at 35%, but the true interest rate is 1.1% more than that. So this is why it's truly just a ripoff.